So the next conic section that we want to talk about is an ellipse. And an ellipse is a set of all points P, so let's put a point on here, P, such that the distance from P and two distinct points is constant. So here's what this means. If an ellipse is a set of points such that if you pick a point and measure from here to this point, so I'm just going to estimate something, I'm going to call this distance 1, and measure from here to here, distance 2, if you add distance 1 plus distance 2 together, you'll get some constant. If you pick another point on the ellipse and add this distance and this distance, you get the same constant. If you pick a point here and add this distance and this distance, you'll get the same constant. So that's what the set of points make up for an ellipse. Different than a circle. Circle is equidistant from one point, but here it's the sum to these two center points. And they're not really called center points, they're actually called focus points. So let's go ahead and label a diagram here of an ellipse so we can kind of know what's happening. So you've got 2 points inside the ellipse, and then you've got the center of the ellipse. So I'm going to start with one that has a center at the origin. So let's go ahead and just draw our ellipse here. We'll make this one longer horizontally than vertically. So these would be this would be the ellipse. Because this is longer than this one, they're both called axis, but we're going to call this one the major axis. And we're going to call this one the minor axis. So since this is the major axis, I'm going to just say this is A units long, and we'll make this one B. So this would be negative B. So since A is longer than B, these are going to be called the vertex. This one would also be a vertice. And we would call these covertices. This one would be a covertice. So the major axis is the line drawn through the focus points. So we would call these focus points. So just like with our parabola, we had one focus point. Now we have 2 focus points. So the formula for an ellipse is going to be different. We know that a circle was x squared plus y squared equals radius squared. But for an ellipse, this is always going to equal 1. But if you'll notice, the center isn't always 1, and it's because we have a fraction of the x value and a fraction of the y value. So what's underneath the x is either going to be a or b squared. What's underneath the y is going to be whatever squared. And what I mean by whatever is however long it is from the center to this vertice point is going to be underneath the x. When you go in the y direction from the center to the covertice, that's the number that goes underneath the y. So let's try to think of one here. Let me graph one with you. I'll just make up a basic one. Let's do x squared over 9 plus y squared over 16 equals 1. And we'll say the center is at the origin. So if the center is at the origin, notice the number underneath the y squared is bigger. So that means this thing is going to be longer this direction than it is in the horizontal direction. So this is x squared over 3 squared and y squared over 4 squared equals 1. So this means that from the center, I'm going to go 3 units in each direction in the x direction. So this is the point 3, 0, and this is the point negative 3, 0. And in the y direction, I'm going to go 4 units. So if I drew my picture right, it should be longer this way than this way. Since it's longer in the y direction, now this is the axis, major axis, and these are the vertices. Since this is the shorter distance, these would be the co-vertices or the minor axis. Okay, we also have 2 points in the center here. I'll have a point here somewhere. Excuse me. The focus are always on the major axis, so they'll be kind of in here and here somewhere. Let me get another piece of paper. So I'm just going to make a real general one here. And I'm going to make this one longer in this direction. So I'm going to make this A0 and this 0B. So if this is the longest one, the major axis, the focus points are going to be on the major axis. To find the focus point, we're going to call that C. You're always going to take the focus point squared equals the longest side squared minus the shortest squared. Shortest squared. Okay. So let me show you what I mean by that. Let's do the ellipse. 4x squared plus 25y squared equals 100. Know that when you're talking about an ellipse, this always has to be 1. So to start this problem, I'm going to have to divide everything by 100. So I get x squared over 25 plus y squared over 4 equals 1. So since the number under the x is bigger than the number under the y, I know this is going to be longer horizontally than it is vertically. So it's going to look something like this. It has a center at 0, 0, and it's going to go 5 in the x direction. So the vertex is at 5, 0, and negative 5, 0. And then it's going to go 2 in the y direction. So the ellipse is going to look something like this. Okay, let's talk about where the focus points are. So to find the focus, c squared is going to be the longest squared minus the shortest squared. So the longest side that we have is 5. So c squared equals 5 squared. Subtract 2 squared. So c squared equals 25 minus 4, or the square root of 21. The square root of 21 is between 4 and 5, so that means somewhere here is a focus point and somewhere over here is a focus point because it's the plus or minus value. Now these focus points are going to have special properties. We know one thing, that if we had a point on this graph, let's say I have a point right here, the length from here to here and here to here, when I add those together, is going to be the same as if I picked a point here to here and here to here. The sum would be constant. Also, the focus points, well, I'll have you do some reading on some other properties of what the focus point is. So let's see if we can write an equation. You're going to want to do this for your third quarter project. Let's see if we can write an equation if we're given an ellipse. So let's say this ellipse has a center at 0, 0. And it has a vertex at 0, 5. And it has a co-vertex at 4, 0. So co-vertex is at 4, 0. So there must be another one over here at negative 4, 0. And the vertex is at 0, 5. So there must be another one down here at 0, negative 5. So since this is longer, it's going to be something like that. So my equation is going to be x squared over however far it goes in the x direction, which is 4, squared, which is 16, and y squared over however long it goes in the y direction, which is 5, squared, which is 25. So the equation for that ellipse is x squared plus y squared over x squared over 16 plus y squared over 25 equals 1. So what happens if this ellipse is not at the center? And this is going to happen a lot on your project. If the center is not at the origin, then standard form looks like this. X minus h squared over a squared plus y minus k squared over b squared equals 1. And remember, this is going to be how far you move in the left or right decision based off of the sign, and it's the opposite sign. So if I had one, well, let's just write one, well, let's do this. X minus 2 squared over 25, and let's do y minus 1, let's do plus 1 squared over 9 equals 1. Let's graph that. So the first thing I would do is find my center. So the center is going to be 2 units to the right and 1 unit down. Now from the center, I'm going to find my vertices by going the square root of this number in the x direction. So I'm going to go over 5. So that would be 7, negative 1. And then I'm going to go 5 this direction. Then I'm going to go 3 in the y direction. And 3 this way. So the ellipse looks something like this. And of course, it'd be much better than the way I've drawn it. Our focus point is going to be somewhere on this axis. So the focus point squared is going to equal 7 squared minus 2 squared. So c squared equals 49 minus 4. So c squared equals 45. So c equals the square root of 45, which is going to be a little bit less than 7. So it'll be somewhere in here.